Tackling the SID was the easy part. The STAR, in almost all cases, is more difficult because it contains a lot more information. Back at Aeroplanner, we know what STAR to use because by now we can pick it out of our flight plan. In this case, it's Glasser 6. Now, I know what you're thinking. When I first saw a chart like this, I almost fell out of my chair. No way am I going to be able to learn all this. However, once we break the chart up into little parts, you will soon see that it's as easy as cake. First, let's examine the chart in a bit more detail. Just from looking at it, I can tell how to orient the chart. Look for the arrows, or better yet, recall the funnel. Once you have the chart oriented, there are a few things that you should be able to pick up on. First, this star serves two airports, Seattle, which is the one that we're going to be flying into, and Boeing Field. This is exactly why stars were created. They can handle a lot of traffic in an orderly way. Let's first determine where we are, or at least where we need to be. For this, we look at our flight plan. The last waypoint on our plan is the Mullen Pass, abbreviated as MLP. MLP is also a VOR because it has a frequency associated with it. It's good practice to get the VOR and a waypoint on your nav display in case one of the systems fails. Just like the SID from earlier, the STAR uses a lot of the same terminology. We know that our next waypoint is Spokane on a heading of 255 degrees and almost 81 miles away. A new description appears in the form of FL 180, which means flight level 180 or 18,000 feet. This is not a hard altitude. In other words, we don't have to be at this altitude. We should not, however, be lower, and it's here as our guide for our descent. We move to Spokane on a heading of 255 degrees on the inbound radial of 73. This is VOR terminology and is beyond the scope of this tutorial. However, looking at a compass, we know that the opposite heading of 255 degrees is 73 degrees, and this is the direction from the Spokane VOR. In other words, we will be flying in on the inbound 73 radial. If you have an FMC, this is not something you need to know for the most part. From Spokane, we move into Temple, which is also a holding point. Holding points are imaginary parking lots in the sky. There are times where, because of traffic, you get placed into a holding position by ATC, or because you are too high. Since airplanes can't just stop, you would circle this waypoint in a holding pattern until you were ready to proceed. Petro is our next waypoint, and from there we move into Swunk. What is the minimum altitude that we should be flying at between these points? If you said flight level 160, then you are correct. Go below this, and a mountain could greet you. Glasser is next on the list, and this is the point where traffic from other directions will meet us. Recall the holding point? If this intersection is busy, you very well may be placed into a hold by ATC. At Jackson, things get a bit more interesting. You need to look at the instructions, and this is something that you should do before you get to this point so that you can plan ahead. For starters, we have a speed restriction in effect. Depending on where we plan on landing, we may have to cross this point at 280 or 250 knots. We also have some hard altitudes that we must maintain. 16,000 if we were landing north, or 12,000 if we were landing south. Now, wait a minute. What were all those other altitudes? Recall that I said those were not hard altitudes, but were there as a reference, or more importantly, altitudes that you can't go below. These, however, are hard altitudes, and you must be at those before you get to this point. This is where planning is very important, and where I recommend programming in the STAR during flight. This way, it's fresh in your mind. We also come across some new terminology at this point in the form of numbers and arrows. We have a 23 and a 37. Jackson is not a VOR, it's a waypoint, intersection, an imaginary point in the sky. What if your aircraft wasn't equipped with an FMC? Well, then your only way to navigate would be to use VORs, and this information would be crucial to you. The 23 indicates that Jackson is 23 nautical miles away from the Payne VOR on an outbound radial of 75. The 37 tells us that Jackson is 37 nautical miles away from the Seattle VOR. Heather is our next waypoint, and depending on where you're landing, you have another altitude restriction in effect. Now, it's worth knowing that at this point, or even before, ATC would start to vector you in, meaning there may deviate you from the flight plan or assign you an alternative altitude. So where exactly are we landing? How do I know what is north and what is south? For this, we need to look at the airport diagram. Seattle is pretty easy because it only has 2 runways. If you're landing on runway 16L or 16C, then you're landing north. If you're landing on runway 34R or 34C, then you're landing on the southern part of the airport. One last thing we need to look at. We're spoiled by the FMC because it gives us a nice representation of where we need to go. However, if you're just using VOR navigation, then the following description is needed, or at least helpful. We look at the Mullen transition because that's the first VOR on a flight plan. So from MLP VOR via the MLP 255 radial and a GEG 73 radial to GEG, then via GEG 257 and PAE 075 to Glasser. From the Glasser intersection via PAE 075 to Jackson, via the SEA radial 023 to the Heather DME. Thank God for the FMC. Try flying this approach using only VOR navigation and you will appreciate how easy we have it.